In part 2 of this experiment, we're focusing on the interaction between magnetic fields and this moving beam of electrons that we've created in our E over M apparatus. So question 1 says to bring a bar magnet near the electron beam in various locations and observe what happens to the electron beam. So you won't be able to see this super well, but I have here a bar magnet, and one end is north and one end is south. Step 2 asks you to check it with a compass, but I've previously checked this bar magnet, and those north and south directions are accurate. And so if I just bring my magnet toward the electron beam, you'll notice a fairly interesting behavior, at least I think it's interesting. And that is the electron beam deflects, and specifically it's bending down. If I bring it towards the beam from the other side, the electron beam bends up. If I turn my magnet around, the electron beam bends down. And if I take the south end in from the front, the electron beam bends up. So what does this tell us? Well, it tells us that the moving charges must be experiencing a force in the presence of a magnetic field. And you can try different angles. So if I bring it from below, it might be hard to see this based on the camera angle, but it bends either toward the camera or away from the camera. And above is harder because the bulb is there, but again I get bending towards or away from the camera when I bring it in from above. If you bring your magnet in precisely from the side so that it's lined up with the electron beam, however, the electron beam doesn't deflect, though it's super hard to actually in experimental conditions line it up precisely so there's no bending. But if you get it lined up exactly, there's no deflection of that beam. So that tells us ultimately that the orientation of the magnetic field and the orientation of which way the charges are moving matters. Question 3 says to imagine a coordinate system superimposed on this system we're studying. So let's call the direction that the electron beam is moving, which is left to right in our perspective, the x direction, the positive x direction. And the magnetic field, the convention for magnetic fields is they point out from north poles. So we want that to point in a positive y direction. That means I'm going to orient the magnet towards the back wall there. And so if my electron beam is moving in the positive x direction and towards the back wall is the positive y direction, what I notice is when I bring that magnet in, the beam deflects downward, which in this three-dimensional coordinate system we've created would be the negative z direction. If I can't do much to reverse the direction of the beam velocity, so the beam velocity is still in the positive x direction, but now if I make the magnetic field in the negative y direction, so I bring the north end toward the camera, I see upward deflection, which is in the positive z direction. These are harder to see, but if I put my magnetic field in the positive z direction up toward the ceiling, I get deflection of this beam that is back in the negative y direction. Or if I flip my magnet around so the magnetic field is now in the negative z direction toward the floor, I get deflection of my electron beam toward the camera, which would be the negative y direction in this coordinate system that we've established.